Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you're doing good. In this, we're gonna see problem. Check if parenthesis string can be valid. Now, as the name itself says, valid parentheses. So I assume that you must have watched very basic naive valid parentheses problem. It's a very basic problem, right? And also on top of it, I'll expect that just to be more close to these kind of problems, please also watch this one video, link in description. Now this problem is more or less same. It simply says that a parenthesis string is a non-empty string consisting of opening bracket and a closing bracket. It is valid if any of the conditions is met. And these are the basic conditions for valid parentheses, which we have also seen in this specific video. Now, you are given parenthesis string s and a string locked. Now, what is this? Again, string locked is also of size n, but locked is a binary string consisting of only zeros and ones, indicating that if the ith index is locked or not. If locked of I is 1, I cannot change it. But if it is 0, I can change it to anything. When I say anything, it can be either opening or closing. I have to ultimately tell if S is a valid parenthesis or not. So just for the simplicity, anything which is unlocked, which means I can change it to anything, I have represented it as star. Although in the code itself, you will see I will use a variable known as unlocked, but for your simplicity and visualizations, I have put it as a star. This star indicates that this thing is unlocked. Now, firstly, I will tell you that forget about this thing. Forget about this thing. What the star is. If I would have asked you simply that there is simple this kind of a string, if I ask you if it is valid or not, how would you have performed it? How you usually perform it? What do you do? Okay, you have a opening bracket. What you do? You just push it in the stack. Like if I put the indexes, then I will simply push the index in the stack. If I encounter closing, I will check in my stack, do I have a opening bracket? Again, this is a very standard stuff which we have already seen in above videos. Again, it's a very standard, that's the reason I'm not repeating it. If I encounter opening bracket, sorry, firstly I encounter closing bracket, I see in my opening bracket I have a opening bracket. Okay, remove it. Then this is sorted. Okay, go on next. Now I am here. It's an opening bracket, put it here. It's an opening bracket, put it here. It's a closing bracket. Okay, check the stack. Do I have opening bracket? Yes. Okay, pair it up, remove it. Get here 5 closing opening, yes I have. Okay, pair it up, remove it, and then go on. Let's say if in worst case I would have had a closing bracket but my stack is empty. Oh, that's an issue, that's an error. What if I had one more opening bracket? Okay, no worries, put the index for it 6, but then if I reach the end my stack is still not empty. Oh, it's actually also an issue. Now why I told you all this is because roughly exactly same thing we will use, but just a slight modification that now I have a star and I will leverage this star. Again, when I say star, I mean this is unlock position. I can put it as either opening or closing. As you can see, if you try to put or replace star with the correct opening or closing bracket, you will see that here the star will be replaced by opening bracket, but here the star will be replaced by a closing bracket. So now just to make a problem statement or example bit complex, I have taken a extended string s. So what here will do, okay, here you can easily see that the star will be modified with the opening bracket, but here the star will be modified with the closing bracket. And also existingly there are correct pairs also. So it is a combination of everything which you might expect. Now I will apply the same strategy here. As you know that I already knew what the opening bracket was. Here I did not know. I have to try both the possibilities. Okay, let's try to firstly make sure that the star is an opening bracket. Now you might ask, Aryan, why as an opening bracket? Simply because I just want to make sure one very basic stuff. As I am moving from left to right, anything which closing can actually counters, which means right now I have three variables in my hand: star, opening, closing, right? So what I can do and what I know with my previous knowledge is I can handle two variables, opening and closing. So what I did was I imagined these two as opening, as you can see star, and this as opening and this as a closing. Now what will happen is now I only have two variables. I just have to repeat the exact same process. Now, when the first process is done, which means that I will try to pair a closing with either the opening bracket or the star. Now, a very quick question for you. If you encounter a closing bracket and you have two options, either to handle that closing bracket from an open bracket or a star, which one will you choose? Obviously, you will try to choose a opening bracket first. Now, you might ask, Aryan, why not a star? Because see, star is actually very much precious metal for us. Why? Because it can be replaced to closing also. So if I will waste it in the beginning, I might not be able to use it in future. So I want to keep it as much as I possible, as much as possible, so that I can use it in future. That's the reason. If a closing comes, I will firstly try to handle this with a opening. When I say handle, what do I mean? As you know, handle means that if a closing comes up, I try to look for in my stack, do I have a opening? Oh, do I have an opening or not? If I have an opening, oh, well and good. If not, do I have a star? Okay, which means I will have to maintain a stack for a star also. Then I will check if I have a star or not. And whenever I say check a opening or star, I'm only referring the corresponding indexes. Now, okay, as this is done, what we will do? We will know ultimately in the end either what will happen. Again, if you remember what happened in the end, when you will reach the end of your stack, what will happen? Again, no worries, I will show you with the dragon also, but I'm just helping you to imagine that if I reach the end, what you know that you will have a opening stack, you will have a star stack, also called as unlocked stack. You have these two stack. In the very end, what can happen? Either you will have a closing remaining. If you have a closing remaining, which means that you don't even have both the stacks as empty. In that case, if you have a closing remaining, obviously the answer is false. Now, which means now if the answer is, or if you don't have any closing remaining, which means there's a possibility that these two stacks have something. Now you might ask, like you might say, Aryan, if these two stacks have something, then are we not saying the answer is false? Because if you remembered, when only the opening bracket was remaining, you told the answer is false. Yes. But if in this scenario, both the stacks have something, then still there is a possibility of the answer. Now you might ask, Aryan, how? Because if both the stacks have something, which means opening stack and the star stack, just take a very basic example. Opening stack has indexes 2 and 3, star stack has indexes 7 and 6, let's say 7 and 5. Then I can always say now the star can start behaving as a closing bracket. So if you know, earlier the start behaved as an opening bracket, then the closing bracket gone, because obviously this will not be used anymore. Now I have again two variables. One is hardcore opening bracket and one is a star. But now in this case, the star will behave as a closing bracket. Now again, I have two variables. Again, repeat the same process and thus get your answer. Cool. Let's show you with the help of a dry run. Obviously you see that I have a star. Again, I'm telling you in the code I will use a unlocked stack, and here I will use a open bracket stack. Now, there is one very, again, for the folks who have seen these videos, they must have started thinking, Aryan, like you started off with the stack itself, but if you remembered in these we discussed the optimum approach also, which does not use a stack. And obviously, if you see very carefully here in this state, you just want, again, I'm going a bit far before even telling the actual approach, but yeah, just bear with me just for a second. That if you remember that we can also solve this by opening bracket and a closing bracket variables, because obviously if I let's say encounter opening bracket, increase the count by 1. If I encounter closing bracket, I will check if the count is there or not, and that's how I can do it. But why in this scenario I will have to use a stack is because obviously for the first iteration where my closing bracket is fixed and the other brackets are considered as open, in that case variable approach will work. But as soon as my both the opening and star are there, now I need to make sure the star will act as a closing bracket, and for a closing bracket its corresponding opening bracket should be in its left side. That is the reason now the count will not matter. I will need to know that for a 7 I should be having a corresponding opening on its left side. If this opening would have an index of 9, this is not a valid scenario, because for a closing on the left side, I cannot have an opening on the right side. That is the reason I will have to use a stack. So let's start the dry run. Obviously, I have a star. Okay, index 0, put it in the star stack. Then again, I got a closing bracket. Firstly, I will check against the opening bracket. Do I have it? Oh, no. Okay, no worries. I will check the star now. Yes, I have it. Okay, remove it. Go on to the next one. Okay, it's an opening. Put it in the opening. Okay, closing. Okay, firstly I'll check my opening first. Yeah, I have it. Okay, remove it. Okay, go on. Okay, it's again a opening 4. Okay, no worries. Again a star. Okay, no worries. Then okay, again a opening. Oh, no worries. Then again a again a closing. Okay, 6. Yeah, remove it. Now ultimately reach the end. Now after one iteration, when I considered my star as a opening candidate, this is my final configuration. As you can see, I have no closing remaining. If I would have had any closing remaining, then I would have directly returned a false. Right now, this is my final configuration. Now I will have to again start and will check a simple while loop, that while my opening bracket, let's say opening bracket is not empty, and also my unlocked as in star is also not empty, right? Simply start getting out the content. But I also told you that I will have to put a one more condition by saying that opening brackets, its top value, it should be lesser than my unlocked top value, because now the star, or I should say unlocked, is behaving as a closing closing bracket, right? And thus this I will keep on repeating it. When I say repeat it, simply pop out both the values. So opening bracket dot pop, and same way unlocked dot pop. Now what if, again, let's say if this process repeats, which means you are removing one values from both the ends simultaneously. if in the end if in the end, obviously this will behave as a closing bracket, this is behaving as a opening bracket. If in the end you are remaining with a corresponding opening bracket, you are screwed up. You are screwed up, because obviously for closing if an opening bracket is remaining, there is no closing bracket, obviously you have a dangling opening bracket which will give you an issue. So just a base case that if not opening bracket is empty, if the opening bracket is still not empty after this above while loop, again you see it's a second if condition, then simply return a false. Now you might ask, have a very basic doubt, Aryan, what if this star is not empty? Which means obviously if this star has a 8, right, like opening is empty but the star is not empty, then I will say I can obviously make pairs in star. Which means that, okay, let's see, if I have 8, 10, 12, 14, I can make pairs like this. So if my star has something, I can obviously make pairs. Now you might say, Aryan, but what if you have odd? What if you have odd? Yes, that is actually an issue. So to handle this issue in the base case, which means in the first case itself, I will have a condition that if my n mod 2 is not sorry is equals to 1, which means the length of the string is odd, then simply return a false. Now why this case will handle this case? Because at every step for one bracket I am removing another bracket. Same way, for one bracket I am removing another bracket. So I'm always removing things in pair. Ultimately, if in the end I have odd, which means in the beginning also I should have odd. It is a simple math that if I have any number which is, let's say, 10, if I am subtracting minus 2 minus 2 minus 2, I'm subtracting even number, I will always achieve a even number. It is same way, even minus even, because again pair simply says even, this is fixed. I will always achieve a even number. But odd minus even, as you can see, 9 minus 2 will give you 7, which is the odd number. Thus this is fixed, this is fixed, this is your input, which is n, this is your input n, and this is the ultimate star remaining count. So if the n itself is even, Ultimately, in the end, star count, remaining count will also be even. Same way here also. And that is the reason you can simply solve it. Let's see the code. Although I have shown you the exact same code early, like entirely also while I was try running, but let's see it once also. So I have a stack. I put it up as an opening and unlocked. As you can see, unlocked is star. Firstly, as you remember, we need to have a base case so as to not handle that remaining star case. Now, I will simply iterate and I will simply say, okay, if it is a star, simply push it in the star stack. If it's an opening bracket, simply push it in the opening stack. Now, if it is a closing bracket, firstly check, do you have an opening bracket for it? Yes. If yes, remove it. If not, do you have a star for it? If yes, remove it. If you don't have anything, neither a star nor an opening bracket for a corresponding closing bracket, you are screwed up. Simply return false. Now, when this is done, you will obviously have a opening and a closing bracket. Simply, sorry, opening bracket and a star stack. Check, both are not empty. And also my opening bracket top should be less than the star top because star will now behave as a closing bracket, and remove both of them. Ultimately, in the end, if the opening bracket is still not empty, oh, you are screwed up again, and ultimately return false, or else you can simply return a true because star will always be having in the even count, and this will be good for you. Ultimately, as you can see, you are using two stacks, you are using a O of n iteration. That's the reason time and space is O of n. Now, a very basic follow-up question. Can you solve this in O of one time? With the existing knowledge, with the previous problems, as I have already iterated before, you might start thinking in terms of using variables. Obviously, yeah, that's the only approach how you can achieve a O of one space, right? So what you will do? Obviously, you will try to use a opening count and a closing. Okay, not a closing count required because obviously I will iterate on the corresponding array itself. For a corresponding closing, I try to see that okay, if I have a corresponding opening count or not. If I don't have it, I'm screwed up. But in this case, for the first step, if I remove it, for the first step, I can maybe do it. How I can do it? Okay, I will simply say okay, I will maintain a unlocked as a variable and I'll do a plus plus. Then I'll maintain a open bracket as a variable and I will do a plus plus. Then in this scenario, I might simply say that if my open bracket, open, let's say OB, open bracket, if it is more than 0, then do a open bracket minus minus. Same way here, the unlocked, if it is more than 0, then do a unlocked minus minus. If still, then return a false. Now you might say, Aryan, it seems like I can use variables. Okay, so far yes. But the main issue comes up when we try to use the same thing while comparing, because here we are comparing the indexes. Here we are actually comparing again. As you can see, if we are putting up something on the stack, let's say it was a star stack, it was an open bracket stack, you are putting something in the stack. Ultimately, the order will be something like this, that in the stack I would have something like 6, 8, 11 and something, and then maybe here something let's say 9, 7, 3, something that sort I will have. So you see that because stack is first in like last in first out, so obviously my topmost thing will be the most extreme rightmost index. So that is the main issue for me. This is the reason why I needed a stack. How can I get rid of this? With using the variables itself. So you are at this point, you have to somehow figure out how to get rid or how to resolve with this portion. With the existing knowledge, which you had, that okay, you somehow can use the variables. So what we will do, let's see. So this is okay, where is my thing gone? Yeah, so we realized that okay, we have again a modified array. For the first portion, we can obviously use a variables as we saw also, and you will see the code is exactly what I told. Again, so far this is the exact same code, and the code which we replaced, this is the exact same code also. Now the main crux is how to solve this. Again, I just don't want to show you, that's the reason I just crossed it. But yeah, the main crux is how you solve this. Let's see. So ultimately, in the end, when you are using variable, when you have a star count, you will see that the star count ultimately remaining will be 1. Opening count will also be 1. And the closing, okay, will be empty. So now your prime thing is that the star will behave as a closing bracket, right? And it should come after the opening bracket. With the existing plan which we saw for stack, we also realized that okay, in the stack ultimately the things are in the reverse order of the top of the stack, and it ultimately hints us to iterate on the array from reverse and try to check the star and the opening. Okay, but we also realize that if we check the star and the opening from the very back, we might need to maintain which star was counted as an opening in the previous step. But for that, I will again have to maintain a opening, which is again an issue. So with all these issue, what we end up realizing is that back to our basics. Basics says simply try to balance a pair. How to balance a pair? Simply maintain that were you able to balance a pair or not. How to do it? Simply see. We will simply say that again. If this is how we will try to balance it. But for balancing, let's try to bifurcate the condition. If my logged would have been, let's say if my log would have been a 0, which means that this is a star. If this is a star, I will simply start imagining that specific thing as something. Like again, I will try to balance this. This balance indicates, am I able to balance my pair or not? Now, when I say am I able to balance, I am now imagining star in this situation as a closing, as a closing, as a closing. So whatever operation I will apply when I see a closing bracket, the same operation I should apply while encountering a star. So if I just put one more condition, let's say else if my s of I is equals to a opening bracket, and let's say here the else if condition if my s of I is actually a closing bracket. So whatever I'm performing with balance here, right? Whatever I'm performing again, let's say I'm reducing my balance as soon as I encounter it, same thing I should do it for my closing also, because this right now, and when I say I'm reducing a balance here, I will have to increase my balance here. Why? Because this indicates a balance pair, which means what is the current pair stat I have. Now you might say, Aryan, isn't it that you are putting up unnecessarily balance? Okay, what if the logged is 0, which means it's a star. You might ask, Aryan, isn't it that you are putting up unnecessarily balance in this, which means that there's a high possibility of balance being more negative? Yes, obviously it is, but we are saying that we have already handled that possibility of closing being the culprit. Now, closing is not the culprit. Culprit can be the opening one only, and that is what we are trying to test here. Which means to test the culprit, culprit is only opening. So I'll just have a simple check. If the balance is more than 0, then simply return false. Because if the balance is positive, which means the opening was the culprit, and I have now at this point in time excess opening bracket. Now, coming on back, okay, this is what we saw. Okay, but this is not exactly what we want to do. We also had these variables, right? Unlocked count, this is, I should say, unlocked count, and this is my opening count. So obviously, as I am moving backward, I will tell what all unlocked count I have. I will simply say that this was my corresponding star count, or I should say unlocked count, and this is my opening count. Simply, as we are moving back and we are moving away from this unlocked value, simply reduce the unlocked count, reduce it. And same way, I will also try to reduce my opening count because I am moving back. Opening count. Now, obviously, we were moving back. And why moving back was the ideal choice? Because the stack maintains the state as last and first out. So technically, we were iterating from the very back onwards. So I will simply say I equal to n minus 1. I is more than equals to 0. And then I minus minus. I minus minus. Now, this seems a bit okay, but at a specific point where your opening count reduces to 0, because this is the only culprit, right? This is the only thing which I need to check for, that okay, is this not causing an issue? So I will simply have a check that if my unlocked count has reached the 0, and also sorry, first should be opening bracket count if it reaches a 0, and also my corresponding unlocked count reaches a 0. Then I will say, and my unlocked count reaches a 0, then I can simply break off from here. It's simple, because you will see that this is the entire thing which we will try to do. Now, why is that the case? You will see, as you are moving from back, you encounter something unlocked, you try to reduce the count, okay, and you also try to reduce the balance, which means, okay, balance, and this balance is separate, like keep these things separate, so this will help you to maintain the corresponding balance. Now, other thing is that obviously you have an initial count which you have to make sure that for a specific opening you are reducing the specific closing also. And as you are saying that I have multiple, if let's say if I build some example, I have multiple opening and closing. Forget if you had something here on the left part. Let's say if you're iterating on the very back, and let's say you had all the openings up to this point. If they are removed, if they are removed somehow, then you don't have to worry about any star or a closing value here, because your openings, what all excess openings you had, are removed here itself. Now you might say, but Aryan, isn't it actually an issue that I am, you know, overly judging something? Maybe it is not that important. If it is, I'm judging. No. Again, this is if you just try to counter yourself. This is what I like, the one which I told just before. It is if you're trying to counter yourself, that what if this happens, you can simply see with the help of try run also, that if you are at the index 7, you will encounter closing bracket. Okay, firstly, I have a unlocked count as 1, opening count as 1. Okay, a closing bracket you encountered. You will try to reduce the balance. Okay, the balance now is -1. Again, you can make it positive also. This you can make it positive, thus it will become a negative, and thus you can put a condition of negative also. That's totally up to you how you want to do it, right? Then I go on to the next index. It's now a opening bracket. Okay, now I will come to a corresponding opening bracket, and I will first increase the balance. It will become a 0. Then I will decrease my corresponding opening count. Okay, my opening count is actually decreased. It becomes a 0. Okay, then I'll encounter a star. As I encounter a star, I realize, okay, this is, balance should be reduced. Balance is now -1. Unlocked count also reduced. Unlocked count, which means the star count, let's say unlocked count, let's say the star count is also now reduced. Okay, if that's the case, what are we saying? Are we saying that this is a good configuration? Technically, yes. But as you can see, the balance is not 0, and you have reached the state where both open bracket count and unlocked count is 0. But now you might ask, but Aryan, isn't it technically wrong that you actually reduce the opening bracket here, but then you are using the star here? Yes, it might feel like, but this ultimately tells us that this candidate, this specific person, was actually handling the closing bracket. Again, understand this very carefully. This tells us that this is handling a closing bracket. So if this you are counting as a star, imagine, just imagine that these are already handled. These cases are already handled. So now the remaining cases are technically these only. This, and this. Why these are already handled? Obviously, and I should also say that this is also already handled technically. But if you want to even, let's say, let me remove this again. Why I'm explaining this very much is because this point is very confusing, because you might easily see that the code is trying to say that the count is reduced for this bracket, but technically the closing one which is being used is this one. That is the reason this makes the people very confused, that okay, why it is happening. It is only because that this person who is right now, we are actually reducing it as an opening bracket, he was never the person who was actually impacting us. There was some other opening bracket which was actually impacting us, which is before, obviously. But in this case, you might actually work out, like this might actually work out for you. Now the issue is start arising Why? If you will remove a balance here, balance from this equation, because balance will tell you if you had some access opening bracket in the right side. Let's take the counter example. Again, why I'm explaining it in deep is because it is actually a tricky statement. If let's say if I take a counter example, if I had only a star, okay, I removed all this also, but yeah, if I have only a star and an opening bracket, then what would have happened? Let's say if I write back that condition, that if my logged of I, if it's equals to 0, then simply reduce the balance what I did in closing, and then also reduce the unlocked value. Now if I had a star here, oh sorry, if I had only these two things, if I did from the back, what will happen? If I encounter a closing opening bracket first, already my balance will increase. Forget about this opening, you will land here, and this is all actually a wrong thing. This is actually a wrong thing. Okay, no worries. Then let's take a counter example again. What if I had a star and like this configuration, oh, the length is itself odd, thus again this is wrong. Okay, let's take another counter example. What if I have something like this? No worries, let's try, let's check. If I land here, okay, obviously I will do something, my balance will be -1. If I land here, my opening count, as you can see, with the above operation, as soon as the above operation happens, my opening count will actually be 1. As my opening count is 1, so again, although in default I have opening count as 2, but after the first iteration my opening count is 1. That's actually the culprit, that's actually the candidate of being culprit. So my opening count, one person is the culprit here. That's it. I just only want to handle one person, but not necessarily this person. I will handle one person and will make sure that everything else is also handled by making sure I have a corresponding balance in place. Okay, this person came up. I will increase my balance again. My balance becomes 0. My balance becomes 0, and then my open count also reduces to 0. Then I land onto my star. Okay, my balance will again become a negative. My unlocked count will again become a 0. Technically, now this will say you have reached a good state. Why this is saying you have reached a good state is because he knew this, because he knew that I am at a good configuration balance. My balance is correct. I had one opening bracket which I actually wanted to handle, and I have already handled that. And with this point, he's good to say that you will be good to go. Why he's saying it? Because he know that one opening bracket you had after it, or it can be before it also. But if you have one opening bracket after it, the total count of opening bracket was already handled in the earlier case with the corresponding opening, sorry, with the corresponding closing bracket. Thus, this opening bracket technically reflects whatever I had previously. If I repeat it again, what this is saying is, if you know the closing is already handled, if the closing is already handled, if the things are balanced up till this point, closing is already handled, things are balanced, which means that if I am saying I had some excess opening, things are balanced here. Excess opening reflects that I would have for sure have the similar openings on the earlier side. If yes, then closing already balanced this, so star will balance the earlier side. And that is the reason how I can solve this. Cool, let's see the code. Again, I tried to stress much more on it because it is very difficult to think of in an interview. Now, exactly as what you can see, that if the thing is a star, simply reduce the balance, the same thing what I did in closing. And also make sure to reduce the unlocked, because the unlocked I have like taken it from unlocked value from this point and the opening bracket value from this point, because these are the, again, this count is the culprit which I need to make sure, and this unlocked count is actually the candidate for being a closing. So if I can handle only this much count, I am good to go, right? And thus I will same way do the opposite of what you did for the closing bracket. Do the opposite, increase it, although you can reduce, like you can change the sign also, it's totally up to you. And then here decrease the opening bracket. This is that how many I am able to reduce, as in like I am able to get to a 0 point or not, right? And as you have reached 0, now obviously this is a simple statement that when you have reached both of them 0, which means okay, you are at a correct configuration point. and then ultimately simply you can break out. And if the open bracket is still more than 0, sorry, you are already screwed up. This is the exact same thing, and ultimately return a time of O of 1 and space of O of 1. Sorry, time of O of n, space of O of 1. Cool. The video is a bit long, but yeah, I hope you guys got it. Bye bye, take care. And if you guys liked it, please like it. Bye bye.